Hi, so I'm Alvaro. And I guess I'm going to tell you about how I became an engineer and why, and some stories along the way. If it works. Maybe not. There we go. All right, so where am I from? I grew up in Mexico. You guys all know where it is, right? Yeah, a long time ago. So yeah, I was born in Mexico, and I grew up there. Since I was a kid, I've been interested in things kind of engineering related. How many of you guys speak Spanish? All right, cool. So this is kind of my kindergarten yearbook photo, and it has a little quote about what, I don't know, anyone, I mean, you want to see, what does it say? Yeah, in English, yeah. Oh, so they got a mic for you.
I like working in everything. Wait. I like.
Yeah, go ahead.
I I like working at school from big to be an inventor.
Yes.
My personality is, my favorite character is Bugs Bunny.
Yes, there you go. So ever since I was a little kid, I wanted to be an inventor of some sort. It's kind of vague, but yeah, I wanted to make stuff. In 2000, my family, we moved to the United States, so we moved to Miami. So yeah, new country, new school, new everything. First thing I saw when I got to school, there was a programming class, and I thought, oh, computer programming, that's super cool. I'm going to make video games. And this will work. There we go. Yeah, that's the first thing I saw was this, which is, I don't know if you guys have heard of QBasic or QuickBasic. This is a programming language that was used a long time ago. So I showed up to this class thinking, oh, I'm going to make 3D games and car racing, I don't know. And I saw this, just a blue screen with some text on it. But I didn't know that many people. I didn't speak English very well, but I started playing with programming. This really doesn't like to work. Do I point it somewhere? There we go. So yeah, this morning I was looking for some of my programs I wrote. This when I was 12, so probably around your age. I made little racing games and just lots of silly things, I guess. But I started programming and kind of enjoyed it. This is actually a program that my dad wrote when I was a kid for me. It was kind of a hangman game where you have to guess the letters. And that's the only one I could find this morning. So yeah, I started programming since I was a kid. There we go. I like making things, so you ignore my lack of fashion. But I was a kid, and my dad encouraged me to build stuff, so I always liked airplanes. So we built a remote control airplane when I was, I don't know how old I was, probably in middle school or high school. So always, I guess, interested in either programming or making things. There we go. This is another thing in high school. We entered an engineering competition to design a suitcase. This had been after September 11th, so they were very interested in designing a new suitcase that was easy for this airport security to inspect. So we came up with this weird design that kind of would unfold. And imagine this unrolls, and you can look at everything inside very easily. So in high school, we put it together and went into this competition. I think we got second place or something. But it was a lot of fun. Let's see. Sorry? I'll keep going. Anyway, Ah, there we go. Oh, so this is a toy gun. This is for a project. Oh, we got a new. Cool. All right, there we go. So at the end of high school, I found out about this robot contest, and that what you have to build was an autonomous little BB gun that would have a webcam, and it would have to shoot at these targets by itself, so fully autonomous. I had no idea what I was doing. I had never made robots that looked with a webcam and stuff, but people encouraged me to just try it out, so I figured, why not? So I got this BB gun online, and I took it apart to see how it worked. So you see it has a little motor, some gears, some springs. So then I put it together, and this is actually a webcam mount. So it's just a little 2 motors that are made for a webcam so it can look around. And I figured it'd be easy enough to just screw the little toy gun on top of it, and then my dad used to have a webcam, and then I took it apart, and then he didn't have a webcam anymore. So it's up here. So I made this little webcam thing, and I programmed the computer vision, I think, in Visual Basic, which is not a good language for computer vision, but it's all I knew how to do. And I got it, I don't know, kind of working. And this is, I guess I had just turned 18, so I went off to Vegas to compete. And I think I got 5th place out of 6, but I was really happy because I was the only, most of the other people were teams, and they were college students and everything. But yeah, you can see here, there's the camera, and I don't know if you guys know what camera film is, but this is some developed film that's actually used as an infrared filter, so I could only see the targets that were infrared. Anyway, it was a lot of fun. I didn't know anything about robots, but I just started opening it up, playing with it, and got something working, sort of. There's another. You can see the targets back there. There are these white circles that it would shoot. OK, so then after that, went back home, and then I went to college. So I went to college in Rochester, New York, the Rochester Institute of Technology. That's my parents when they delivered me in college and were really sad. So I went to college for electrical engineering. I had a passion for software, but also wanted to learn more about hardware and electronics. And I decided electrical engineering. I figured I've been learning how to program on my own, so I can keep doing that, maybe take some classes in programming, but mostly I learned electrical engineering, which has all the cool equipment in the labs that I can't get at home by myself, so I might as well do it at the school. So I did that. Oh, here's a little circuit. I mean, you guys have breadboards. This is same, just with a little more. This is a little microcontroller. I don't know if you guys have heard of Arduinos, but that's, I think, it's the same processor in Arduino. It's an AVR. This was one of my first experiments making printed circuit boards. So first I prototyped it. I tried it out on a breadboard. And then I made my very first printed circuit board because I wanted to see how they worked. I didn't really do much with it other than build it, solder it all together, and then I could write little programs on it, make lights blink, talk over the serial port. And it was mostly an experiment in making circuit boards because, I don't know, it seemed like a good idea at the time. OK, so during college, I also did some traveling and studying abroad. So after my first year of college, I decided I'm going to learn Russian. Again, it seemed like a good idea at the time. And then I went to Russia and lived abroad there for a bit. Came back, continued my studies. And then the reason I chose Rochester Institute of Technology is most colleges, it's a 4-year program. You study for 4 years, and you graduate, and you become an engineer. RIT, it's a 5-year program, but one of those 5 years is required for you to be working. So a full-time job or internship, paid internship. So I would do 2 years of school, and then I did 6 months of just a full-time job. So my first internship, I worked at this company. They did railroad track switches, remote control railroad track switches. So imagine, the train tracks. Whenever the track switches from one side to the other, we could remote control those. So I wrote some software to control those things, which is a lot of fun and dangerous. So I did 6 months of that, got a lot of experience in industry, and then I went back to school. And then after that, I found out there was work abroad programs. And I say, I love to travel. I have to do an internship. Why not do an internship while traveling? It's kind of like a paid vacation, but you get to work and learn. So I went to Switzerland, and I worked at a research institute where they used particle accelerators for cancer treatment. It was a proton therapy device, and I worked in some software for that. And then I came back, and I kept going to school, and then I really liked going to Switzerland, so I was like, oh, let's go to Finland instead. You guys know where these countries are? OK, sorry. They're in Europe, and then Russia is so big it's in a few different continents. So then I went back to Finland, and I worked on GPS receiver software. So you guys know GPS, how you find yourself with your phone and other things. So the GPS satellites are owned by the US, but the European Union is launching their own satellites called Galileo constellation. So we did some research with those. Anyway, it was a lot of fun. I learned a ton, and I had to come back. OK, so then I graduated. They actually gave me a degree somehow. I did my master's degree as well. I just kind of did it all at once. I did a thesis and all that fun stuff. OK, so I graduated. My first job was Texas Instruments. Have you guys heard of Texas Instruments? Anyone? Calculators, right? Yeah, so I didn't do anything with calculators, unfortunately. But Texas Instruments also makes microcontrollers and electronic components. So this is a development board a friend made, actually, with the C2000 processor. It's just a processor I was working on while I was there. And I was writing all the software libraries for our customers to use. So imagine you're a company, you want to make a motor controller circuit. You buy this processor, and then you put it on your circuit board, and then you program it to do motor control stuff. So Texas Instruments will have their engineers write a lot of example software so that you as a customer don't have to do it all from scratch, which is really slow. So anyway, I worked in Texas Instruments. I lived in Texas. It was fun. And then I came to Maker Faire. Have you guys heard of Maker Faire? Yeah. It's happening next weekend. I hope you guys go. It's a ton of fun. So I was living in Texas. Do you have a question? Oh, cool. Yes, it's always fun. I love it. You guys, if you haven't had a chance, make sure you get to go at some point. So I was living in Texas, but I met people on the internet, and I had my friends. We worked on projects and circuits and programs and stuff, and they're spread all over the country, but they were all coming to Maker Faire. So I decided, I'm going to fly to Maker Faire to check it out, meet my friends in person. So I came to Maker Faire, and I loved it. Everyone's making things. It's super inspiring. It was great, and it was here in California. Completely randomly, I ran into a friend that went to college with me. I was just walking outside the train station, and I run into this friend, and he's like, hey, how's it going? What are you doing here? I'm like, oh, just come to Maker Faire. Oh, cool. Bye. And then he left, right? So it's just a very random meeting. The next week, I'm back in Texas at work, and I get a phone call from my friend. He says, hey, Alvaro, how do you like Texas? Wouldn't you rather live in California and work for Apple? So I was like, oh, yeah, that sounds great. So I started interviewing at Apple, and then I got a job at Apple, and I moved here. Yeah, that was my nickname. We'll get to that. So I moved to California a few months after Maker Faire and started working at Apple. I worked in a group. We did kind of research and development. So we worked on prototypes, new concepts, internal tools, which I can't talk about. But it was a lot of fun. I got to work with some really, really smart people, lots of cool product. You guys know about Apple, right? You've heard of it? Small company around the area. Yeah, so while I was at Apple, I was unfortunately known for having accidents from time to time because I like to just try things. Sometimes I don't quite understand how something works, but I just go poke at it, figure out how it works by trial and error, which is not always the best engineering-wise, but it's a fun way to learn. So yeah, I worked at Apple. While I was at Apple, I worked on various projects at home. which I can talk about, luckily. Remember that robot project I told you guys about, the BB gun? That was in 2006. In 2013, or 2014, one of those years, they decided to bring it back. They said, hey, let's do that contest again, but this time instead of having a BB gun, because it's kind of dangerous, and this was in Vegas, and the casinos don't like it when you have BB guns inside the casino, so they said, let's make it with lasers, because lasers are awesome. So now we're going to have laser shooting robots. All right, I said, that's going to be awesome. Let's do it. Why not? I have no idea how to make a laser shooting robot, so I'm going to learn. And I don't know if you guys have heard of Tech Shop, but it's kind of a, you guys, yes? It's kind of a shared workspace that has all these cool tools, including a laser cutter. And I said, hey, I want to figure out how to use a laser cutter. So I decided to start designing my laser shooting robot using a laser cutter. You can see here there's two different versions. One of them I made by hand with a knife and some wood, and the other one's with a laser cutter. I don't know if you guys can tell which one is which, but yes, I made this one myself, and then I used the laser cutter. Then I decided, oh, wouldn't it be nice to use computers to design this instead of just making it by hand? So I learned a little bit of CAD and computer-aided design to kind of model my robot. And then I laser cut that. And then this is one of my many iterations. I think I have a video. OK, yes, I have a quick video. I made this before Maker Faire because I had a Maker Faire exhibit, and the laser shooting robots were coming to visit. So let's see. There we go. So this is how I started. A tiny, again, a webcam mount. Then this is my hand-cut one. And then I had a webcam that would actually track the targets with some computer vision, right? I also made targets that would turn off. This one didn't work. This one kind of worked. This one did not work. So this is the one that actually went to the competition. You can see it moving around. That's a PlayStation camera, by the way. So this was Maker Faire 2 years ago, so if you go to Maker Faire, you won't see this, unfortunately, not this year. Anyway, yes, so we made that. Then that year, before the competition, I said, hey, wouldn't it be cool for Maker Faire to show the laser shooting robots at Maker Faire? Because it'll get me motivated, and I'll be done earlier, because I procrastinate sometimes. But then I said, laser shooting robot, it's super cool, but it's not a very interactive exhibit. It's not very exciting. So I decided to make a shooting gallery, something that people could participate in. So this was more of a little game that you had to shoot these targets with a laser, and then the robot would be shooting against you on the other side. That would be more fun for people. So here's a quick video, just super quick, of how it worked of a Maker Faire project.
3, 2, 1.
So this is just my little Maker Faire project. And there's people playing. And when people weren't going against each other, they were going against the robot. But by that time, the robot wasn't quite that good. So it sometimes would lose. Yeah, so that was that. Oh, yeah, well, yes. So anyway, that was Maker Faire a few years ago. And that was super exciting. All right, so I don't have the pictures, but I actually went to the competition, and we got first place. My friend helped me out, and we actually won. Thank you. And then I actually won a quadcopter. This is a really small quadcopter. I got a really big one for winning. So then I started getting more interested in quadcopters. And then some friends brought one. I get pizza with friends every week, and a friend brought one of these guys to dinner. And it's about the size of the palm of my hand. And it's so much fun. They're like $30. You could fly them around and crash them into things. So I got really interested in them. And I had seen another person online doing what's called reverse engineering. Have you guys heard about reverse engineering? Do you guys know what it is?
It's like when you try to find out how something works by taking it apart.
Yes, exactly. So finding out how something works by taking it apart. It's another way I like to learn things. So I was very interested in these quadcopters, and I wanted to learn more about them, and I wanted to learn just more skills on my own to figure out how they work. So I decided, let's take it apart, figure out how it works. So this is a little quadcopter. You see there's a few little integrated circuits on there. One's a processor, one's a radio, and the other one's a gyroscope and accelerometer. That's how it knows its orientation. And this is the remote controller, the control part of it. And you'll see how I soldered all these wires onto the processor. So what I'm doing is I'm measuring all the voltages, all the signals coming out of the controller going to the radio to figure out how they work. And this is a logic analyzer. So this is a tool that you can connect to a circuit, and it will show you on your computer all the signals going through. And if it's a communication, like some sort of serial bus, you can actually see the data there. And I can start figuring out, OK, so it's sending a command to go up or go down or turn left or turn right. So I would measure the signals as I am moving the controller up and down or left and right. And then I can figure out what all that data means. After I did that, I removed the microcontroller. So I removed the brains of the remote controller, and I plugged in my own. So I was using this just as a radio, and then I was using a program that I wrote to talk to the quadcopter. So now I was able to control it from the computer instead of having to use this. This is a really quick video of the very first time I tried using my computer to fly the quadcopter. All right, so this is a Proto X remote that I took apart. I removed the main microcontroller, and I connected the radio through SPI to this other microcontroller that I've programmed, and is connected through USB to the Mac. So here is a little quad, a little Proto X there. And now I'm going to run my code, and it's going to connect to it and just give it some throttle. So that was the computer flying the quadcopter. Of course, the computer doesn't know where it is or what position it's in. All it knew was, like, turn it on and see what happens. But that was just the beginning. So I learned about how the radio works. Then, instead of having to take apart the controller, I made my own using that little radio module I ordered on eBay. That way, I could just directly connect my computer to this and control any quadcopter. Not only could I control the quadcopter, imagine you have your own, and you're playing with it. I can have this, and I'm listening, and I can see the signal going from your controller to the quadcopter and say, I don't want you to fly anymore. I can push a button, and it will just fall out of the sky, which is kind of mean, but it was a fun little experiment. Another thing I did after that is, hey, I want to be able to fly with my PlayStation controller because, and again, it seems like a good idea. So I used all the things I learned to write a program to do so. So this is a quick experiment. I have my little Proto X remote board, little Proto X, and a PS3 controller connected to my computer. I wrote some code that hopefully works. Yep, there we go. Woo. It's a bit sensitive. Ta-da! Yeah, so again, just fun. So just from this little toy project, now I know how to use a PlayStation controller, which can be used for driving robots, for doing video games, for all these things. I know how to control a quadcopter, and I know how the control talks to the quadcopter. So I learned all these new technologies just by playing with it and having fun. And this is not at all work-related. OK, so after that, the following year, they said, we're going to do the robot contest again. But this time it's going to be harder. Now, I forgot to tell you guys how it worked, but there was these ping pong balls were the targets, and they were in a model railroad tracks, the little train, and they would be running around this track, and then the robot would have to follow them and shoot them. The time I won, all you had to do was hit it with a laser, and then you got points. The following year, you actually had to send data through the laser. So you would turn the laser on and off really fast and actually send data, send your name, sort of, to actually register or get points. So I was like, oh, that's cool, but this time I want to make it completely over the top. So instead of having motors that move my robot around, I'm going to use two little mirrors, and I'm going to move those mirrors, and they're going to move the laser. So you have a laser over here, then you have the mirrors, and then the webcam. This was a completely different project. Before, the camera would move with a robot, so you can always know that the middle of the camera is where the laser is going to hit. This time is completely different. Your camera doesn't move, and the laser moves all over the place. So there's some more math involved to figure out where the laser is going to go. I don't know if this is kind of dark, but you can see the laser beam going there. And this is a green laser. It's brighter. But anyway, we built that. I think we got third or fourth place this time. But it was tons of fun to see everyone's robots doing stuff. All right. So then after Apple, I heard about this company called Planet Labs. These are satellites. You guys know what satellites are? They're in space, and they do things. So these are Earth imaging satellites. There's actually a telescope in here that takes pictures of the planet. So I heard about this super cool company called Planet Labs that makes these tiny little satellites. They're about this big. That's almost, they're smaller than they show up. And they launch them, and they take pictures of the planet. And I found out some of my friends were working there, so I wanted to go visit them. And then I started working there a few months later, because it was a lot of fun. So we build these satellites in San Francisco. And they go around the Earth, and they take pictures. And the special thing about these satellites is they're really small, and they use the same components that you would use on a computer or a cell phone. They don't use super expensive space-grade components. They use just normal consumer electronics, basically, which was really cool. Yeah, so that's where I worked and did stuff. I've worked on other sillier projects, for example, for work. We had, have you guys seen the movie Back to the Future? Yes? OK, cool. So our holiday party was Back to the Future themed. And I don't know if you guys know what that is. A flux capacitor. So I'm not very good at costumes, but I made a flux capacitor to wear to the party. So this is a simple project. Just for fun, right? I wanted to build one and then use a little microcontroller. So these are little things I like to do on the side. OK, so this year, we'll get to this. They wanted to do the robot contest again. But this time, instead of lasers, we wanted to go back to actual things that fly. So they wanted to use, I'm sure you guys have played with Nerf guns, right? Yes. But instead of dart, they have these ones that are these foam like spheres. So I was starting to play with it just to get an idea of what it would take. This is actually the mechanism that's inside of these Nerf guns. It's two flywheels that spin really fast, and then the foam ball goes in the middle, and it just gets shot out. So I was trying it out. I wanted to test the mechanism. This might be a little bit loud. Yep. No Furbies were harmed in the making of this video, I think. It's still there. Yeah, so that's mostly it. I didn't know how much to cover, but that's kind of where I am right now. So if you guys have any questions, I'll be more than happy to answer them. Yes, I think they have microphones.
How long have you been doing this?
Doing what?
The building?
Oh, building? I mean, since I was a kid, I think. When I was little, I would build Legos. That was my favorite toy in the world. I built Legos. Then I there was some metal, I don't know what it was called, but, like the erector set or something it's called. Then I started programming. Then I started playing with robots. And these things I started more in college and then after college mostly. But I've been building all my life, I guess. Yes?
What made you start building and like doing engineering stuff?
Oof, what made me start building? I don't know. I don't remember when I started. I've always been building. I mean, my dad was a huge inspiration. He fixed anything, right? So I would always see him building things, fixing things, and I guess I got inspired and I wanted to do that. And yeah, just seeing always, like I said, I wanted to be an inventor, and that I must have been like 5 or 6 years old at the time, I guess. And I don't remember back then, so I've always wanted to do it.
Great. So I've got a question back here.
Question, sure.
Do you like to do flying objects or shooting objects?
Flying objects or, sorry?
Shooting one.
Or shooting? What do I like better?
Yeah.
Flying objects that shoot would be pretty cool, but I like the flying stuff a lot. I've always loved things that flew, but the shooting robots are a lot of fun as well. Here?
How many competitions of engineering have you won?
Have I won? Define win. First place, not that many, but so I got the DEF CON bots. When I was in high school, I would do programming competitions, which are a ton of fun. So if you guys ever get into programming, try going to competitions. They're loads of fun. I would do those. There was the suitcase one. Yeah, I mean, I guess I haven't competed that much. One here, or here.
Did you enter any other projects in Maker Faire?
That was the main one I did, was the shooting gallery with the robot project. I want to do one this year, but I didn't have time. I do have some more I want to do in the future, for sure.
What are your current projects you're working on right now?
Current projects. So I think I'm going to start working again on the thing that shot the Furby, make that better and easier to control. I want to do more reverse engineering projects to learn how stuff works. There's the bigger quadcopters, and those radios are much more complicated. So there I would use a software-defined radio, which can listen, just radio waves and then decode it. So yeah, a lot of reverse engineering projects and stuff like that. Yes.
What was your first project that you did?
My first project that I did. Wow, does a Lego count? Because I made lots of little Lego robots. The first one I did, like electronics related, I remember in 7th grade, I had to make a movie for history class, I guess. So we decided to make something about Vietnam War. And back then, digital video editing was just starting. So we decided to record everything out of order because, we can just edit it in the computer. Except that didn't work. So we had to go back to VCRs and playing and pausing. And I wanted to add sound effects to my movie. So my dad, I didn't want to buy a mixer, like an audio mixer, because they're expensive. So my dad showed me, you could just make a very simple circuit to do this with a transistor. So we got all the parts and used the breadboard. And that's what I used to mix the audio signal from my special effects to my video. And then I made a little tiny printed circuit board of that. And so I'm around 7th grade. Any other questions?
Any other questions? I thought I saw some hands up before. I have a question for you. You mentioned a second ago, someone else had asked a question about how many competitions have you won. And I thought that your reaction to that was interesting. Can you explain a little bit about what winning means to you in the competition? And is it necessarily always getting the first place, or is there something more than that you feel like you gain and that other people gain?
So I'm I'm not all about the winning, I guess. I like the participation aspect of it, because I usually learn a ton just by competing, either from other people competing, I will learn how they did things, or from me just, even though for example, the first time I did the BB gun robot, I had absolutely no chance in winning. But if I hadn't even tried, I wouldn't have learned that I could build robots, that I could make things move, that I could program computer vision without ever having taken a class in computer vision programming or anything like that. So I see the competition more of the challenge to myself to actually build something. Just getting to the competition, you already did better than most people, right? Because a lot of people always, oh yeah, it'd be great to compete, but very few actually even make it to the competition. So just being there for me is already something. And if you do make it, that's even nicer. But most of what I get out of it is just being there, hanging out with like-minded people and learning. Yeah. Any other questions? No?
I think I have 25 more questions. But one more question is, you mentioned a little bit about the satellites you were working with.
Yes.
And what was some of the work that you did with that company working with the satellites? What were you actually getting them to do? You said images of Earth.
Yes.
And how was that? What kind of projects were those for? Was it working towards helping someone with something or monitoring something? What kind of projects?
Yes, so the goal of Planet Labs, the company, is to take a picture of the entire planet, of all planet Earth, every day, which right now nobody can do. So right now, big satellite companies will go with a really nice satellite, and you will pay them to take a picture of a certain place. And they will take a picture of that place with really high resolution, maybe every several weeks or months or years. So Planet Labs is launching lots of little satellites to take not quite as high resolution, but pretty good photos of the Earth. So imagine a ring of satellites spinning around the Earth, going around it, just taking pictures. And what we did with the pictures is you sell the photos, but also whenever there's a natural disaster, so for example, there was fires in Canada or earthquakes, they provide those photos to help out with rescue or with recovery and all that stuff. You're able to catch deforestation. So do you guys know what deforestation means? Anyone? No? When people, yes? Yes, so they cut down forests, and most of the time illegally. So someone goes in a forest and cuts down trees without asking permission. They're not supposed to. And most of the times, people don't realize it because it's in the middle of nowhere in the forest. With these satellites, if you're taking pictures every day, you can notice, look, someone's cutting down trees. This happened yesterday or 2 days ago. So they can actually go and do something about it. They found illegal gold mines, I forget in which country, but just by looking at the photos. Question? Oh. Go ahead.
As we know, engineers are always looking into the future. What do you see for yourself maybe in the next 5, 10 years?
That's a tough one. I like making things that help people, just something right now I don't know. I want to learn as much as I can and then build things. So I'll look at something at some point and hopefully realize that I can make something better and hopefully do something like that. You had a question?
Does it orbit out of the atmosphere or in the atmosphere?
Yes, it's in low Earth orbit. So you guys know about the International Space Station? So the actual picture you saw, those two satellites were actually launched from the International Space Station. So they go up in a rocket to the space station, and then the astronauts will put it in the arm, and then they will kind of use a spring to shoot them off the side of the space station. That's how we used to do it in very small quantities. But now they're going in bigger rockets, and they're launching a lot more at a time. Question?
Yes, more or less. How much does it cost to put one of these satellites in orbit?
That's the only thing they won't say. Yes, but it's a lot cheaper than bigger satellites. Yes, orders of magnitude cheaper.
All right. Any last questions here from our team? OK.
Yes.
With all those personal projects that you've done, how do you go about documenting like your, let's say, ideas, improvement, and like future?
YouTube. So I like to make YouTube videos. I have a blog where I write about some of my projects, and I post them on Twitter, on Facebook. It's really helpful. I really enjoy sharing because people will make comments, will say, oh, you could do it better this way, or that's super cool, I didn't know you could do that. And having a community or people asking me, hey, how's it going with so and such project, it really makes me want to work. Because if I work on projects and just keep them to myself, it's not very exciting. And I like being able to share it, and maybe other people can learn from my mistakes, because I make lots and lots of mistakes. So if someone else can see me fail and not do that again, it's a good, here.
From the time you started your career till now, how have you seen the progression of women's involvement in STEM subjects?
Whoa. So that's a tough one. I mean, being in electrical engineering in college, there weren't that many women, unfortunately. And it's been fairly, you do see that in various companies I worked at. They're making a kind of big push to recruit more women. I did a bunch of recruiting with Apple and stuff, and it's getting better. But yeah, no, definitely there is a problem. Yes. Oh, sorry.
What inspired you to do your projects and do all those robots that you do?
What inspired me to do it? I mean, laser shooter robots are just exciting. I just like working on that stuff. But the very first one, it was something that seemed super cool. I wanted to go to Las Vegas to this conference and compete. And actually, I'll tell you the truth. Originally, I thought I was going to be working with someone else on this project, but then they bailed on me. And I had to just like, I already started, let me just finish it. And then I did that. And the following ones, I had such good memories of building that I wanted to kind of bring that back and learn more. Yes?
Do you like using your computer, or you like building it yourself?
Ooh, so making like hands-on stuff instead of computer design?
Yeah.
Ooh, that's a tough one. I like both. I'm definitely much better at making things with computers, so programming, in all the mechanical aspects I'm learning. So a lot of these projects, the reason I do it is to learn how to make things by hand. The robots, all the laser cutting, the computer design, the lasers with the mirrors, all that stuff, I had absolutely no idea what I was doing. I just said, I'm going to make this project, and I'm going to make it in a way that will force me to learn all these mechanical things. And now I know much better. So I would say I prefer computer stuff, because that's what I know. But I really like to learn new things. Question?
One more question.
So I don't get a lot of allowance. I actually have to kind of sew my own stuff. But since I don't have a lot to spend, how do I get started in something like that with not much money? How do I do like little electronics things when I don't have a lot of money to spend?
I mean, a lot of these, maybe the laser cutting and stuff. I know a lot of I don't know, companies or tech shop and stuff. There's a lot of tools you can use without spending too much money, because I can't afford those tools, right? I know for students, there's great resources. I don't know if some schools have all the tools. For electronics, like an Arduino is fairly cheap. I don't know if you guys know about the folks at Evil Mad Scientist Labs, which is it's a local company. They make a lot of these kits, and they make electronics kits. So there's a lot of these things that you can get started with. There's electronic surplus stores that you can go to. If you guys are ever curious, go to an electronic surplus store, HSE or Halted, I guess. And you can get parts really cheap. And there's tons of information online about how to build these things. You have a question? A blog? Yes. Yeah, so yes, my YouTube, and then my blog is just my name, alvaroP.com. I don't know if we can put it somewhere.
We can share that with everybody.
It's just my first name and P, Broadcom.
Great. Any last questions from our audience? No? Well, I have one last question. You've shared a lot of passion and enthusiasm with our students and our audience today, and I'm wondering if you can share any words of wisdom or advice. As these incredible students, you've already seen them working today with Raspberry Pi and doing some physical computing, and as they take off into their futures, what advice would you give them so that they can pursue their interests and such as well?
I would say a couple of things. One, if you do want to learn how to program or you want to learn something, I really find helpful to have a project or a goal in mind, right? So if you want to build a robot and it's like, OK, I'm going to learn to program to make this robot, it helps a ton other than, oh, I'm just going to learn to program. If you don't have some sort of goal, it makes it much harder to get motivated to do it. And on the other hand, like I said, don't be afraid to try something even if you don't know what you're doing. I had no idea what I was doing when it came to building mechanical things, but I tried it anyway. I failed so many times. It took me months to get it right. I didn't have time to show you all the failures, but those are online. But yeah, don't be afraid. It's not going to work. Just keep trying, and you're going to keep learning. Or learn from other people's failures. So go online, look at YouTube. There's so many cool videos of people working on electronics and stuff. Yeah.
Great. Thank you so much. You've been an incredible inspiration, great rock star. Big round of applause for Alvaro. Thank you so much.